This was years ago. We used this as like a pop quiz just to see if people were understanding where we're at. But this is more just like, let's think about the different concepts that we can use in order to start proofs. But let's go on the very first one. Friends, true or false? Sine x plus cosine x is equal to 1.
False.
True or false? Which one is that?
False.
This should be false. What would make it true?
The squared.
Yeah. So if we go sine squared x cosine squared x equals 1, then we were going to end up having it true, because then it's its identity. So be careful, because that's the stuff that got you guys on your identities quiz, was the fact we forgot the square. Okay. Is tangent of x equal to sine x over cosine x? If you did not know that, I have totally failed. And my methods of teaching that have gone totally downhill, because we've been talking about that before we really even explained why that was true. Okay, so here's what we're going to do next. We're going to talk about, like, if this was one side of a proof, what would you do? Like, if this was the side of the proof that was the icky or ugly looking side, what should we do? So here's are the choices. You're going to factor by guess and check. We're going to pull out a greatest common factor. Find a common denominator. Maybe factor by difference of squares. Should we FOIL or distribute? Do we convert everything to sine and cosines? Do we use factoring by grouping or substitution of a Pythagorean identities? Or we could even say substitution of like other identities too. Like when they say convert everything to sine and cosines, aren't we actually using identities in order to do that? So yeah, so that's using that same type of idea. So this is like, imagine in your brain that this is the side we're working with. What would you do? This is where it's just practicing how to start. Sometimes that's the hardest thing to do. What would we do? All right, the first one, we have a cotangent x and we have a sine x. What would you do if this was the side you were working on? Yeah, you would change the cotangent, right? You change everything to what? Sine or what? Cosine. So our first step when we're working with it, I want to see if I can change the color there. Oops, wrong one. We would sit there and go, oh, cosine x over sine x times sine x. So we would have used sine or cosine probably first. And then right away, what happens with your sine of x? They cancel out, and we get the fact that is cosine x. So you can really just almost physically see where that first step would be. Probably because you guys have done it enough now. They're starting to, like, you're starting to get starting spots in your brain. Like, okay, maybe I'll try this when we're working with it. Okay, now next one's kind of fun. We got secant x plus secant squared x plus secant cubed x. We haven't seen anything like this yet. But what would you possibly think to do? I'll probably do what you said. The moment I saw 3 terms there, you were going to think maybe factor, right? So exactly, you're going to want to take out, where's my red at? Okay, this gets me in trouble every time I try to move this out of the way. All right, so with this one, you're going to take out your greatest common factor. Okay, so what is that greatest common factor that we take out? Yeah, so we take out a secant x, and then we get 1 plus secant x plus secant squared x. So that would be our start for that one. Now someone goes, what would I do next? I don't know, because we don't have the other side to have a clue where we wanted to go next, right? So that's okay. Then we look at the next one. We got cosine to the 4th x minus sine to the 4th x, which means we're really taking cosine x and raising it to what power? Or sine x to the 4th power, okay? When you're looking at this one, what do your instincts tell you after what we were doing yesterday? Yeah, we can factor this one. For a lot of you, what way would I factor this one? Yeah, isn't this a difference of squares? Because when you have any even-powered exponent, right, is a perfect square. So when we do this, this is a difference of squares. We get our plus and our minus. So this would be cosine squared x, sine squared x, And then what do we get here? Cosine squared x minus sine squared x. Okay, and then what would be the next step, just because I'm sure you guys already see it? The 1, right? Okay. Do you remember this from yesterday? Cosine squared x minus sine squared x. Does anyone remember what that can also be? This is one of your identities from yesterday. First of all, is this one a half angle identity? No, because the half angle identities were like always fractions or you had the square roots, right? So not having, which means we're going to which one? Double angle. Which one is it? Is it sine of 2x or cosine of 2x? Yeah, that's going to be the cosine of 2x. Guys, you just did the proof probably. Okay, when you're working with that one. All right, first one here, we got the quantity 1 minus cosine x times 1 plus cosine x. What would be our first step of doing this? If this was our first step on a left or a right side when we're verifying the identity. Yeah, you would totally FOIL this. So guys, let's FOIL it real quick. So if we are FOILing this, we get 1 plus cosine x minus cosine x minus cosine squared x. Which, by the way, doesn't that give us a difference of squares? Because those, remember, conjugate binomials give us the difference of squares. All right. Can anyone tell me what that would be? We're actually using some really good skills today. Yeah, that's sine squared x. Guys, notice you're not instantly having to check, but it helps to have your identities up. Definitely, because you're going to want them today a little bit more. All right. Cotangent x plus tangent x. Yeah, this one, when I'm looking at that, this is just probably screaming sine and cosine on there. Probably because we have no idea what the other side is. So in doubt, should we put cosine x, let's just say sine or cosine first. Sine or cosine, changing it. And then we just go, okay, cosine x over sine x plus sine x over cosine x. And just out of curiosity, we're not going to do the next step, but what would be the next step? Probably, in this case, common denominator. So you're starting to see the patterns now. Remember that just last week you guys were like, no patterns like this. We're not seeing this. Now you're starting to see the different ways that you can do this. All right. 2 sine squared x minus 7 sine squared x plus 3. This is brand new. We haven't seen one like this yet. What does that feel like? It's like we foiled it, right? So what's the opposite of foiling? Factoring by what? How many terms? So trial and error, right? So when you see this one, you need to think like factor. I don't know why I didn't put that on there. Here we go. Factor by trial and error, or guess and check, whatever way you want to say that, right? So let's do it real quick. That was that very first worksheet we had before of our algebra review skills. All right, is there a greatest common factor? No. So what are our signs inside the parentheses before we do anything with numbers? Minus, minus. Go a little bit more this way. Guys, factors of 2 sine squared x. Yeah, 2 sine x and what? 1 sine x, right? Awesome. Factors of 3. 3 and 1. Where should I put the 3? Where should I put the 1? So this side, right? Yeah, because if we do a quick FOIL in our head, we do the OI of it, we get a negative sine x plus a negative sine x. It's negative sine x, so we got it good. Now someone goes, why is that very helpful? Forget me right now. Solving equations later, that's huge. That we're able to do this and recognize that when we're having those. All right, feel good about this one so far? All right, here's the next one. I know what you guys are going to say for this one. Thank you. Because you've seen this start like this before. Sine squared x over cosine x plus cosine x. Yeah, it's the common denominator. Would you guys agree?
Yeah.
Put that over 1, and then you're going to use the common denominator. Excellent. So with the common denominator, guys, what would we get for this one? That'd be sine squared x plus what? Yeah, cosine squared x over, and then we could just use our Pythagorean identity, correct?
Yeah.
So, nice. All right, you guys are starting, like, I'm loving this because I'm not even, like, telling you, like, someone is always answering now. This is a way huge improvement. So this is very good. All right. Secant squared x times cotangent squared x. And honestly, you could probably think of this one a couple different ways. I'm curious to know how you guys would do it. Substitution, what type of substitution would we use? Yeah, I would totally use our identities that would change things to sine and cosine. Completely would be the process to do this. Now, here's some other ones. Could we use maybe like the fact that tangent squared theta plus 1 could go in for secant squared x? Or maybe we know cosecant squared x minus 1. It really would matter what the other side would be if we were going to use like a Pythagorean identity or something like that. But yeah, I would do the same thing. I go my cosine squared x, and then I would totally have cosine squared x over sine squared x. Guys, what does that simplify down to? Yeah, 1 over sine squared x. Okay, keep going, just out of curiosity. What do you get? Yeah, cosecant squared x. If that's what they wanted us to find. All right, my friends? Not too bad. All right, are we done on this side? Yep, gotta go back down onto the other. Oh, this one's awesome. What would we do for this one? Yeah, first thing I would do is I'd rewrite it so I FOIL it correctly. That's exactly what we want you to do. Guys, don't forget foiling is huge. I still see people make this error at this level of math of going 1 squared plus tangent squared x. We're done. But honestly, what is that going to give us? That's 1 plus 2 tangent x plus tangent squared x. That, and then who knows what we were supposed to do later in this stuff. Okay. I always just want to know what they're doing. I want to be able to open my window and look. Anyone else feel like right now with that sign outside? Like yesterday, I knew they were pouring concrete. I just didn't realize it was on the 2nd floor. And then I heard they were singing while they were doing it. Okay, sidebar, sorry, I'm putting this on the video. But I asked Emma, I said, did you hear the concrete? Like when I came, there was like 2 concrete trucks, and then I had to go get my international daughter because she was on the furnace tour on my off period, which first period, because Mr. G's out of town. And then like by the time I was there was like 6 cement trucks. I'm like, oh, they're pouring in the base. I'm thinking they're pouring what?
Yeah.
This one. So no, so I go online because I can go online. And I'm like, I'm gonna go online and look at the construction cam and I want to see what they did. So I went, I'm like, no, it was the 2nd floor that they poured. Which I'm glad they did, and it makes sense. I'm like, that's why they didn't put the walls up. They wanted to be able to pour concrete. Oh, go figure. But I was just like, and then I go, Emma, did you hear them do that? Because I know she had some classes upstairs. She goes, Mom, and they were singing. Yeah, they like their job. I didn't know what to say. They like their job. But I sing for math, but I only do that to help you guys learn. Just saying. All right. I'm weird. I know it's Friday. Okay, there's less of you than normal, so we'll just go with it. Okay, secant squared x plus cosecant squared x. What would you guys do for this one? What would be some things that you possibly want to do? Some people said sine and cosine. I actually think that could be a good one. I also think there's another valid one that possibly could work. How about a Pythagorean identity? Because we have the squareds, could we possibly plug something else in? Now, I think sine or cosine would have been my first instinct, but I just want you to realize it could go either way when you're working with this. So like if you were doing Pythagorean identity, we would have something more like if you're doing the identity one. You'd have like 1 plus tangent squared theta. But again, how do you choose which one? It's what's going on the other side. And like here, you know, you'd have 1 plus cotangent squared theta. I mean, it's possibility. That's if I want to use Pythagorean identity. Or I also like the fact that you go 1 over cosine squared x plus 1 over sine squared x. And then I'm looking at that going, hey, common denominator, to work with this one, because I can easily see that I can get another Pythagorean identity. So there's your start, either one. All right, how about this next one? If you guys do not say this one right, I'm going to cry. Yeah, 1 over cosine. So to do that, that's using the Pythagorean identity, right? We're going to use that first. Okay, and you guys all know what goes next. That clock. Or not. That's 1 over cosine x. What is that? Yeah, you can see that secant x is going to be there. That's just using our basic Pythagorean identity that everything's really built off of on that one. Yeah, that one's kind of easier to see. All right, how about the next one? What would you, I actually think that would be a smart choice. I think distributing would go really well, and then after distributing, I think changing your secant to 1 over cosine would be a good choice. So if you distribute, you could go cosine x times secant x minus cosine squared x. And then I would probably, again, who knows if we're doing this right because we only have one side of this, but I would probably go like that. Wouldn't you guys? And cosine times 1 over cosine x is what? 1 minus cosine squared x. Well, what's 1 minus cosine squared x? Beautiful. Sine squared x. Excellent. And that's all with the concept of just distribute. Now, could I have changed secant to 1 over cosine first and then distribute? Absolutely. Either one is a valid way to do it mathematically. Okay, I think that was the end of this column, right? This is what I get for having it enlarged, so I can't see where we're at. This one, what would you do? That's 1 plus secant squared x. What's the possibility of this one? That looks like a what? If I see a 1 plus something squared, is that kind of the idea of a Pythagorean identity? Yeah, and that's probably where I'd go with this one first, is I'm going to use one of the Pythagorean identities. So like, what would I possibly put in here? Well, I could easily replace secant squared x with what? 1 plus tangent squared x. Maybe I will replace the 1 with something, right? We don't know. But the fact is, this would be like a possibility of what you could do. Again, we don't know if that's the right choice because we don't know if that's on the right-hand side. We're just saying, like, what is a possible start for this? Okay. The next one, we got 16 secant squared x minus 25 over 4 secant x plus 5. What would you guys do first? Someone said GCF. That was a smart thing. That's what you should look for. But what would we do? That's a difference of squares. So our difference of squares is what we would do first. How about we do it real quick? In the numerator, what would that factor into, scholarly ones? That it won't be erased, so it's going to go here. Sec squared.
Oh, just regular. Secant x.
Secant x.
Plus 5. And then I said minus 1.
Yep. And then, oh, we get 4 secant x plus 5. Now that they are common factors, can I take that out? Actually, I'd probably go back and do it one way this way first. So you don't want me to go back. I do like this. Yeah, then it works. Again, is that really what we should be doing? I don't know. I gotta see another side. I use the other side a lot in order to give me hints on what I should possibly do. Like, what are my goals? Do I want something with a double angle in it? Or do I want something without it? Do I want only in sine or cosines? All right, with this one, we got sine of x times the negative tangent squared x plus secant squared x. What do you guys think? Just guess. You guys, you could change it to sine cosines could be a good idea. I think you'd create more work if you did right now. You'd actually create more work if you did that right now. Friends, what if I did this? Secant squared x minus tangent squared x is a Pythagorean what? Identity. It's one of the sub-identities you're supposed to have memorized. So if you saw that was a negative tangent squared x, these two mean the same thing. So isn't it really an identity? So someone goes, well, what would you put down here? I would say switch it, use your commutative property, and then use your Pythagorean identity. Because the moment you do your Pythagorean identity, what lovely number is that equal to? Also, that was way easier than all that other stuff. So don't forget to look for those. And that's why it's going to be really important that you memorize them this weekend before our quiz next week, right? Yeah, so we're going to make sure we have... What?
Monday or Tuesday?
I think it's Tuesday. We have to do it Tuesday just because everyone's been on.
Oh, yeah.
Okay. It's like, no. All right. Guys, talk to me. I got a cosine cubed x plus cosine squared x minus cosine x minus 1. Yeah, absolutely. Because there's how many terms? Yeah, so this one I'd be factor by grouping. I don't know why I cannot stay consistent with colors today. Yeah, factor by grouping. Let's try it real quick. If we look at it, we look at the first two. What can we take out? Yeah, cosine squared x. And we get left with cosine x plus 1. Cosine x plus 1. How do I change a negative cosine x minus 1 to get a positive cosine x plus 1? What do we take out? Yeah, we take out a negative 1. All right, so then you take your GCF out. That's a cosine x plus 1 times the quantity cosine squared x minus 1. And then really, we don't know what to do next because do we have a clue where we're heading after that point? I mean, you could put in something else in for cosine x or something like that. But we literally just did a factor by grouping problem. All right, does this help you to even think how to start things? These are just tools that possibly can help you. We have not spent a lot of time with the idea of factoring, but that is where we're going to get you to go. So we have some problems that we're going to be working with that will get you there. Okay, with the person next to you, these are not long proofs. There's no person next to you today, so sorry about this. For the rest of you, there's only 2 groups that have people next to you. So somewhere near someone else, could you create a group, like maybe girls, you're together, maybe Paul and Katie, you're together. So Fano and Simeon, are you guys doing that? Just create a group. Can you do the 2 identities real quick? That way you also have someone to do homework with, because you guys seem to like that. What's up with that, right? I'm going to pause this and roll your comparison. I don't know on the second one. All right, so let's do this one real quick. On this one, obviously the ugly looking side is the left side. So what? Now what do I do?
I choose to do cosecant.
Now, you can either distribute first or change.
Yeah.
I think either one's a good method of doing this. So a lot of people, I think, change this first. Did you guys? Now, okay, what else can we do? Like mathematically, I either can get a common denominator or can I just distribute? So if I distribute, sine x times 1 over sine x is what lovely number? Minus what's sine x times sine x. Okay, ooh, I forgot my equal signs. Oh, how hypocritical. Okay. What's 1 minus sine squared x? All right. Not too bad. Would you guys agree?
Yeah.
Now, could you get a common denominator, do the same type of stuff? Yeah, but not as much fun. All right. I think, Kristen, I should have had you do, you should just put cosine squared x for the identity of that numerator when you did the common denominator inside the parentheses. And then it would have worked out perfect. Sorry, I didn't think of that instantly. Okay, now, when you're stuck, what is a skill that we used on up above that we haven't used tons of yet? If you're stuck, look for factoring. Because changing everything to sine or cosine just went out the window, right? On this one, because it's already done. So think factoring. So on this one, look at the numerator. Is there anything I can do? Yeah, pull out the sine x, right? So I get sine x times cosine x plus what? 1. What about the bottom one? I got it. What about the bottom one?
The cosine.
Yeah, so we can take out a cosine x, and then we get 1 plus cosine x. My friends, is there any common factor? The cosine x plus 1 and the 1 plus cosine x, are those the same thing?
Yes.
So then I get sine x over cosine x, which equals?
Tangent.
All right, so here's really the new skill. If you're really stuck, try what? Fair enough, because you've got all the other identities and things on there. So homework is just going to be a general identities. Some of these you've like done before, even type worksheet. So that one, that's it. Like nothing really new, nothing harder, no new identities. Just if you're stuck, try what? Try factoring. Excellent.